Hello and welcome to my final Android application. This is the Pokemon application. You can see we've got it started up here. Let's go back to the beginning. So this is the landing page that we have for the Pokemon application. And here you can see we have the Pokedex and the instructions. You can see we also support French, and this scrolls whenever it's overflowed. Here we can type in a Pokemon to search for. So a Squirtle, for example, and this will hit the API. The API will return some JSON, among which is the link for this image. And then what we do is we take it to the JSON service that parses it into a Pokemon object that has all of these fields: name, generation, species, height, weight, evolution line, and description, and types. And then that populates this page over here. And this Pokemon activity will also have its own callback function for a new API call, which will then retrieve this PNG image. This is called getSprite. So if we look in our networking service over here, you can see there are two callbacks here: PokeSprite DL, which returns this bitmap image, and connected with result, which returns the Pokemon JSON. This is used whenever we use connect with the Pokemon query string, and then afterwards the image that is returned from that will be the sprite URL we use in getSprite. And then once this is done within the background thread and it rejoins us in the main thread, it'll then kick it over to PokeSprite DL. And PokeSprite DL is implemented within the Pokemon activity. So we take a look at the Pokemon activity here, and at the bottom, not at the bottom, and over here you should see PokeSprite DL callback function, where it takes the image, which is empty at first, and then it populates it with the bitmap image that is returned from the API. Here we have a save as well, which is an insert here. We can say, yes, we want to insert Squirtle into our local storage. And there is a callback function here that just logs that it's a success, and it logs the Pokemon that was inserted. And over here, we can go to our local PokePC, which is a recycler view of all the Pokemon that we have locally in our database. This is under Pokemon PC here, and as you can see, it has a callback function called retrieved all Pokemon, which updates this adapter with all the Pokemon information that have come back from the database. And as such, you don't have to persist it to app, because the database call will be done whenever the state changes. So whenever the emulator stops lagging, you can see nothing happens. We still have all of our information, even if we rotate the screen. Now we can click on Squirtle that we just saved, and you can see that this kind of view is also working whenever we have it in landscape. This is a different page, however. This is saved Pokemon. And what happens is that saved Pokemon actually has all this information come back from the local database, except for the PNG, which is still used using the networking service. We still make a network call to get this sprite from the image URL that was saved along with the Pokemon data. And we can click on this delete, and we can say we want to release the Squirtle back into the wild, and then Squirtle is no longer in our local storage. To prove to you that this is local storage and that's how this works, what we can do is we can stop the application, we can restart it, and whenever you click on this button, you can see it's all the same Pokemon that we had before. Now I just want to really quickly go over how this is all working. So all of this comes from the database manager, which has a bunch of asynchronous activities for inserting, retrieving, and deleting Pokemon. And all of these have callback functions which are implemented in the respective activities that use them. In our case, for example, saved Pokemon has the delete button, so it has this callback function for deleted Pokemon. And then it kicks back the intent to this recycler view activity, which is the Pokemon PC, so that you can see that it has in fact been deleted from your local storage, because this will then use the get, and it has a little get callback, which I think we talked about a moment ago, that repopulates or changes the information that the adapter, the recycler adapter, shows here. These background colors are actually dynamically taken from the JSON and from the Pokemon object. Basically, if the Pokemon object's first type is fire, it's going to be orange. If it's electric, it's going to be yellow. And this is determined by the comma delimiter here. The types string is split on commas, and the first type is then used to retrieve the background color that we're going to be using. This happens in both the Pokemon activity and the recycler view here. Now let's just take a look really quickly at what this would look like if we were to change the language back to English, because this does support multiple languages as well. So English United States, the emulator is going to lag a little bit here. We click it, going back here. All of this information actually comes from the API, but if we click on one of them and it goes to the next activity, once the emulator stops acting up because it lags a little bit when you switch the language, you can see that the species, height, weight, description, name, all of this is in English now, and it will take it a moment here to actually load the PNG, because this is actually, as I mentioned before, always coming from the networking service, and the networking service will then retrieve the .png and it will make it a bitmap image, and the bitmap image will populate the image attribute within our view. And as you can see, the image finally came back with the Pichu image that we were looking for.